Greetings! In this video I'm going to show you how to use your Nspire for a basic linear programming problem. Here is the plan of the video. Let's use this example as a problem. We are given 3 inequalities and we need to find the feasible region. Here is the answer of the question. The middle darker area is the feasible region. But instead, we generally enter the opposite inequalities on our devices to see unwanted region shaded. Then the feasible region will be clear enough to identify the points that we can use to optimize our problem. Let's open our calculators, press menu and go to graph settings. It is a default view, but we will not need second, third and fourth quadrants, so it is better to start with changing the window settings. I like to start with -1, then I can see the axis. X scale I will make it 1 because we will need the grids to identify the corners, to identify the coordinates. And make Y scale as 1 as well. Okay, so it's my default view at the moment. I would like to see the grids. So let's press menu and settings. Fourth option is no grid. I am changing that one to line grid. As I mentioned before, I will be entering the opposite inequalities. Let's press tab. And when I delete the equal sign, sixth option will let me enter equation in any form. So first one is x less than or equal to 1. And again, the blue region is the unwanted region. My solution will be on the right hand side. Second inequality, press tab. Y is less than or equal to x. You can press Ctrl equal sign for inequality signs. It is the second one. And press tab once more, type the third inequality. Okay, this unshaded region is my feasible region, and every corner point is part of my solution. Let's identify them. Menu, geometry, point. I'll select the first option and click on the corner points. Five points here, and we have 9 points in the feasible region. We can also identify the coordinates of these points. It's obvious from the diagram, but if you go over any point and press Ctrl menu, you'll see coordinates option, and you can identify those one by one. Also, if you are looking for intersection points of any lines, you can also use this option. You can press menu, go to geometry, points again. This time fourth option is intersection points. You need to click on 2 equations. So this one and the red one and the blue one, we already selected that point, is 1 and 1. And let's say the expression that we would like to optimize is 5x plus 2y. So we can just substitute these points on the expression and check which one will give us the minimum point. Or with your calculator, of course, we have a better way. If you press Ctrl I for the new tab, you can select the list and spreadsheet. So you can just put the title for each column. And you can enter your coordinates here. 1 and 1, 1 and 2. And 3 by 3. Okay, we would like to test these 9 points on the expression 5x plus 2y, but we don't want to do it one by one. If you click on column C, the gray area that's called formula bar, and start typing equal sign, you can write 5 times, and if you press variable, you will see title of the column A. You can select 5x, then keep writing, plus 2 times Again, press variable. This time select y variable. So we typed our equation 5x plus 2y here, and when I press enter, we will find all 9 points and their values respectively. We were looking for the minimum expression, so it seems 7 is the minimum one, and they didn't ask this time, but 21 is the maximum one. So it is not a surprise actually. So we are trying to minimize 5x plus 2y. So if I keep x as small as possible, which is 1, and y as small as possible, we will obtain the minimum value. So let's see it on the region. 1 and 1 is the corner point of the region, and the other point 3 by 3. It is not a corner point, but it is an integer solution close to the corner. Remember that maximum or minimum always occur at the corners or near the corners of the feasible region. So we don't have to test every single point, but just we need to select the corner points or the points near the corner and test them on a spreadsheet. Thank you all for watching. I just wanted to give basics of sketching linear inequalities in these videos, but there will be another linear programming video coming soon. Please don't forget to subscribe.